Let us start discussing the rules of probability. We shall begin with the addition rule and the inclusion-exclusion principle. Consider an example. Suppose we want to place an order for some light bites. And we have two options, burger and pastry. Let ordering the burger be event A and ordering the pastry be event B, and let these events be represented by these two circles. Before we proceed, recall the symbols, union and intersection which we discussed in the first video. The union denotes the or condition and requires addition, whereas the intersection denotes and condition and requires multiplication. Now, first we will talk about the mutually exclusive events where the occurrence of one event precludes the occurrence of another event. So, considering that we can only order one of them, what is the probability of ordering either burger or pastry? That is, if we order burger, we will not order the pastry, and if we order pastry, we will not order burger. Here, we are talking about the probability of happening of either A or B. Based on the above table, we can write it as probability of A or B equals probability of A plus probability of B. And since these are mutually exclusive events, so both cannot happen together. Therefore, A intersection B becomes equal to null, and this is what is generally known as the addition rule of probability. Now let's extend this. What happens if the events are mutually non-exclusive? In that case, there exists a possibility of both the events happening together, which is particularly this shaded region. So, while applying the addition rule in such cases, we need to exclude that probability. Then, we write probability of A union B becomes probability of A, so we are considering the first circle plus probability of B, the second circle. However, if we observe carefully, this shaded region has been considered twice. So, we need to exclude it for once. So, we will subtract probability of A intersection B from here. Since A intersection B is not equal to null now, this is commonly known as the inclusion-exclusion principle in probability. Now let's consider that one more item is included in the options, an ice cream. Then, using the principle of inclusion-exclusion, we can write the probability of A union B union C now. However, if we observe carefully, we will find that we have removed the common region between these three circles completely, which we need to add that back again. Then, we can include the probability of A intersection B intersection C here. This becomes the inclusion-exclusion principle for three events. Similarly, we can find the probability of occurrence of either of events from any number of mutually exclusive or mutually non-exclusive events. Now let us consider an example problem. It says that, in a deck of 52 playing cards, let event A be drawing a red card and event B be drawing a face card, Jack, Queen, or King. What is the probability of drawing either a red card or a face card? And these are the options available. You can pause the video here and try to solve by yourself first. Alright, now let us see the solution. First event is drawing a red card, as there are 26 red cards in a deck, diamonds and hearts. So the probability of A becomes 26 by 52 or 1 by 2. The second event is drawing a face card, as there are 12 face cards in a deck, Jack, Queen, King, for each suit. So the probability of B becomes 12 by 52 or 3 by 13. Also, there are 6 red face cards in the deck: Jack, Queen, King of Hearts and Diamonds. Then, the probability of A intersection B becomes 6 by 52 or 3 by 26. Then, using the inclusion-exclusion principle, the probability of drawing either a red card or a face card will be given as, which, upon solving, will be equal to 8 by 13. So, option B is the correct choice. Let's consider one more problem. Here, a task is assigned to 3 persons, X, Y, and Z, whose chances of completing it are 0.5, 0.3, and 0.4, respectively. We are supposed to find the probability that the task will be completed. You can pause the video here and try to solve it. Now, for the task to be completed, it has to be done by either of X, Y, and Z. Then, we can apply the inclusion-exclusion principle here to get this relation. Also, notice that completion of the task is independent for all 3 persons, which means that whether the task will be done by either of them does not depend on others' performance. Recall our discussion about independent events in the first video. We can write the probabilities of intersections as the product of individual probabilities, like this. Which upon solving becomes equal to 0.79 or 79%. Therefore again, option B is the correct answer. That will be all for now. I will see you in the next video. Meanwhile, practice more problems on related concept and do subscribe, like, and share if you have not done that yet. Thank you.